Topic for the day is binomial distribution. The lesson objective is to use GDC in solving problems from binomial distribution. The introduction to the topic is a quick recap of the theory that we should know before we start solving the questions. A binomial distribution can be symbolized as, here x denotes the discrete random variable which is distributed binomially with the parameters n and p, where n stands for the number of trials and p is the probability of success. Now, what is a binomial distribution? The binomial distribution is a type of distribution that has two possible outcomes. We call it the probability of a success or failure of the outcome of an experiment. For example, if you consider tossing a coin, you can have head or tail. So that is the two possible outcomes, and that is a simple example that you can have for a binomial distribution. Now, looking for the key conditions that need to be checked to analyze a binomial distribution or to confirm it. What is the random variable x counting? How many trials are there? It should be a fixed number of trials. That means n should be a constant. The trials should be independent of each other. That means what happens in one trial should not alter the probabilities in the next trial. So the number of trials should be fixed and independent. What is the probability of success in each trial? And that is given by the letter P, and again P should be fixed. So these are the 4 points that you have to remember while handling a binomially distributed data. Let's discuss an example. A coin is biased so that the probability of a head is 0.74. The coin is tossed 7 times. Find the probability of getting exactly 5 heads. What is the random variable counting? It's counting the number of heads that you get. So your success is getting the outcome as a head, and here the number of trials. So you have the coin being tossed 7 times. So your n is going to be 7. And the probability of success. Now your variable is looking for getting a head. So this is the probability of success, getting the head. So your p is going to be 0.74. So we can define the variable as, you're going to find the probability where you have x being exactly equal to 5. So you're going to get a head as your outcome for 5 times. And the data is binomially distributed with n equals 7 and p is 0.74. Now, how are we going to use the GDC to find the value for this, or the probability for this data? Before that, there should be one more part that needs to be analyzed. What if the question is find the probability of getting exactly 5 tails? Now, in this case, the random variable, you're going to count the outcome of the number of tails that you get, and you want exactly 5 tails. So in this case, again, the number of trials remain the same, but the probability is going to be 0.26. So why is it 0.26? Because the probability of getting a head is 0.74. So the probability of getting a tail should be 1 minus 0.74, which is 0.26. So please be careful when you have questions like this. Make sure what is the random variable counting so that you take your probability according to it. And the remaining calculation remains the same. You're going to find what is the probability. So let the random variable of getting a tail be a. So a is going to be equal to 5, and it's being binomially distributed. So this is how you denote it. Just quickly summarizing the GDC steps. The first step is to look for the distribution. You can see DISTR, distribution here. So how will you get this option? It's second and wars. So you have second and wars giving you distribution. And when you click on distribution, so this is the window that comes, and you just scroll down. You keep scrolling down till you see the option. You have binomial PDF. Can you see this? BINOM. So binomial PDF, and you have binomial CDF. So here, press enter. Now from this window, it's easy because we know the number of trials n, the value for probability, and what x stands for, what is the random variable. So these are the windows to expect. Now the confusion is whether you will take option A or B, and when to take a binomial PDF or when to take a binomial CDF. Let's answer those questions. When to use a binomial PDF and when to use a CDF. Option A, binomial PDF, finds the probability that exactly x successes occur during n trials and the probability of the success given equal to p. That means for conditions where you're going to find the probability of x being equal to a particular value, let it be 4. So in this case, wherever you have an equal to sign, you use the option A. Okay, so you have an equal to condition, you use this option A. So maybe these lines can help you remember. You have an A when you have equal to sign. Option B, binomial CDF, is used whenever you have inequality. You can see it's a successes or fewer successes occurring during n trials. So for example, when you're dealing with the probability of x less than 4, or whether it can be the probability of the success being greater than 4, or it can be less than or equal to, it can be probability of x greater than or equal to. So whenever you have inequality, you go for binomial CDF, which is option 2. Now it gives you the cumulative probabilities. Now what do you mean by cumulative probability? For example, if you're finding the probability of x less than 2, that means you're finding the probability of x equal to 0 plus probability of x equal to 1. And so this is how you get the probabilities getting added. So in these conditions, you look for binomial CDF. Moving on to the next part, always remember it is only for the equal to sign that we use option A, which is binomial PDF. Now let's use the GDC to find the probabilities for the given conditions. As introduced in the beginning, the step 1 in your GDC is second. You click on second and wars to get the distribution. Now for the first question, the probability of x equal to, so for sure your equal to condition, you'll be selecting binomial PDF, and the number of trials, it's going to be 10. The probability here is 0.3, and the x value here is going to be 7, and you just press enter twice, and in your GDC you get the answer as 0.009001692. I'm just writing the complete calculator display so that you know you're getting the right answer. Now for the second question, you have probability of x less than 7. So less than means you're going to use binomial CDF because we want the cumulated probabilities. So binomial CDF is what you're going to use, and the number of trials is going to be 10. The probability is 0.3, and here we know they're talking about the variables, the value for x going to be less than 7. So probability of x less than 7 means we need the sum of all the probabilities that is mentioned here for all the values of x. So to find this, we are going to use binomial CDF, and the value for x should be entered as 6. So because you're going to get the added probabilities from 0 till 6. So this is the 6 that you enter here, and you get the answer 0.9894079. So I'm just writing the complete display so that you can check whether you're getting the same answer. In question C, you can see the probability that they are asking for is when the value for the random variable x is less than or equal to. Now in this case, again, it's an inequality, so you're going to use binomial CDF, and the number of trials again 10, the probability is 0.3, and the value for x now equal to 7. That means along with this they want the probability of 7 also, so you will put a 7 there. Make sure you're using binomial CDF and not PDF here, because again you want the cumulative probabilities, you want them added, and then you just press enter twice and you get the answer here as 0.998409. So that's the calculator display. The last question. Now for the part D, they are asking you for the probability of x greater than 7. So in this case, it just means they want the probability of x equals 8 plus the probability of x equals 9 plus the probability of x equals 10, because you have a maximum number of trials taking 10 there. In this case, you can do it in two ways. Either you apply the equal to condition, binomial PDF for each of these probabilities, you find the value and then you add, or it is enough to subtract, the total probability is 1. From 1, you just minus the probabilities of x less than or equal to 7. Let me use this figure to explain this part of the question. Now what you want is the probability of x greater than 7, so which means greater than 7 is this region. The total probability is 1, so from 1 you just subtract the probability of this part, which you have already found, which is for probability of x less than or equal to 7. That will give you the answer for the probability of x greater than 7. And the answer here is 0.0015903. This should be your GDC display. Moving on to the last section, which is dealing with conditional probability. I'm sure you understood by seeing this line here that you have a given that condition that comes after this line, and let's see how can we solve that. Now as per the formula, we know the probability of A given that B has already occurred is probability of A intersection B over the probability of B. So this is the formula that we are going to use. Now let me apply this into this given question. We'll start with the denominator. The denominator is exactly the B part and this is the A. So probability of B, that means you want to know the probability of X greater than or equal to 2. Now for your understanding, I'll be drawing a figure here. The total number of trials, this is your N and this is your probability. Now N is 6, so you have 0, 1, 2, 3, 4, 5 and 6. And you're looking for a condition for the numerator where it is greater than or equal to 2 at the same time less than 2. Okay, I'll be using the shading method for better clarification. It's less than or equal to 4, so they're talking about this region where you have less than or equal to, so 4 is also included, and the B part is x greater than or equal to 2. Now x greater than or equal to 2, so you have 2, it's equal, and greater than 2. And look for the region where you have the overlapping happening. Now from this we can clearly see that the value of x is going to be greater than or equal to 2. At the same time it's going to be less than or equal to 4. So this is the numerator part that we are going to use. 2 less than or equal to x less than or equal to 4. So that's it. You can use your GDC to find the value. So you'll have probability of x equals 2 plus probability of x equals 3 plus the probability of x equals 4 over the probability of x greater than or equal to 2. Now again, the probability of x greater than or equal to 2 can be found by just subtracting 1 minus the probability of x being less than or equal to 1. That's enough. Or you can just subtract the probability of x equals 0 plus the probability of x equals 1. So this should give you the answer for the probability of x greater than or equal to 2. So use these methods to find the numerator and the denominator and divide them, you get the final answer.